guys, it's Thursday afternoon and all's quiet here, but I am currently on a plane on the way to Philadelphia to see my oldest son swim at Franklin in Lancaster, Pennsylvania. But I wanted to bring this lesson to you because I just am going to miss you. So I just wanted to make sure that you heard from me exactly what it was that we were going to be learning. And really what we're doing today is an extension of what we did the last time I saw you, which was the sum of the interior angles of different polygons. And if we can remember, and remember our notes, that if we have a polygon, like this is a quadrilateral, it's a four-sided figure. And so we know that in a quadrilateral there are four different sides, and if you remember how many triangles that makes, 4 minus 2 is 2 triangles. Do something like this. Each of those triangles has 180 degrees, so the sum of the interior angles of a quad equals 360 degrees, because that is 2 triangles. Now if you remember again, the general formula is the number of sides minus 2, that gives us the number of triangles, so n minus 2, you got to put that in parentheses because that's the number of triangles times 180. That gives you the number of degrees on the inside. And just to remember from when we were cutting out the shapes, cutting out the triangles, that as the shapes got bigger in terms of the number of sides, then the triangles that we were cut were getting smaller and smaller. And the relationship there that we're going to talk about in a little while, not today, but maybe next week or so. But this is going to be really important because now you can say whatever number of sides there are in a polygon, let's say that there are 15 sides, or let's take 15 sides, then you know that there are 13 triangles, 13 times 180 is whatever, and that gives you the number of angles on the inside. So this formula right here is really, really, really important for you to remember. Today though, we are talking about exterior angles. Not the inside angles, but the angles formed when we extend the lines of the polygon, in this case a quadrilateral, and what the degree measurements on the outside of the polygon are. So I'm going to show you this one. Again, we're going to take this quadrilateral. It's not a trapezoid, kind of looks like it, but a trapezoid would definitely have the base sides, or those opposite sides, as parallel, and that's not necessarily the case here. But this is also example 18 on page 217 in your book if you want to follow along. But you know, what we're trying to do is we're trying to see what the angle measurement of the exterior angles are. Okay? And some of those right now are variables, and you know that we tried to come up with the exact number for the variable. We're solving for it. So what I want to do here is just show you something really kind of basic so that you'll remember what it is about external angles that we're trying to get you to remember. So what I've done in preparing for this lesson is I've taken this angle right here, which is angle X. It is supplementary to this interior angle right here, so you should know what it is already, but this is something I'll talk about in a minute. But I cut out angle X right here, and we've cut out angles before, and it's to fit right in here, so that matches angle X. I've also done the same thing with angle B down here, which was already given to us at 102 degrees. So that should fit pretty nicely in there. And then I've done the same thing for this angle over here, which is 103 degrees. Oops, let me get that in there so that it fits. And finally we've got another unknown in Y. Okay, so that is angle Y right there. And the reason why I wanted to do this was just to give you some color here so that you can see the angles that I'm talking about, these external angles, the angles that are formed when you extend a line, and we know that we can extend a line because lines go on forever. and then the sides, so it's the angle that's formed from the extension of one side of this quadrilateral with another side. So these are all external angles. And what I want to show you, if I can find this, is that when you take these angles and you actually take them apart and put them back together again, kind of like we did with a triangle to form a straight line. Okay, where do I want to put this? Okay, I think we're going to go with this way. Okay, it's not going to be perfect, as you know, but we're putting them together like this, all of these angles. And if you notice that when you put these together, this is not going to, let me do this one like this. Okay, that's a little bit better. Of course, my drawings are exact. But when you put them together like this, the exterior angles add up to be a circle. And we know that a circle is 360 degrees. When we add up these external angles, and that goes for any polygon, does not matter what sides there are, for any polygon, the external angles are going to add up to be 360. Get some tape for this guy. Okay? And we can spend more if you want, but just so you know, these add up to be 360 degrees in a circle. So let's use that information. Okay? So exterior angles, 360 degrees. This is another one of those rules that you can always use as part of your rationale in your proofs. So let's take a look at this one and solve this one then. All right? So we've got x over here, we've got y, we've got 103 degrees, and we've got 100 degrees here. So there are 4 external angles to add up to 360 degrees. So the first thing that we could do is we could add 103 and 102 together to get the sum of known angles. And hopefully you guys can do that in your head. That's a total of 205 degrees. In order to make an entire circle, the two other angles, x and y, have got to equal, what's 360 minus 205? It's 155 degrees. Okay? And that's because of that rule that says that the exterior angle sum is 360 degrees. So we know that this plus this one has to equal 155 degrees. We talked a little bit about this at the very beginning. It's a supplementary angle to 89. If you remember, supplementary means that two angles add up to 180 degrees. They're also adjacent angles, by the way. So you know that this has got to be the difference between 180 and 89. So that is 10 minus 9 is 1, 17 minus 8 is 9. So this has got to be 91 degrees. And then finally, okay, we need to figure out y. Now we don't have an internal angle here to help us with the supplementary. So we've got to rely on the fact that this one plus this one plus this one, and then the balance of 360 equals this one. So we know that these two are 155 plus 91 is 146. Is that right? No, 246. Sorry. 246. And so now 360 minus 246 is 114 degrees. So this one equals 114 degrees. Okay. So the main thing is that the exterior angles add up to 360 degrees. You're going to use that information along with all of the other information that you know about with polygons and with parallel lines and transversals and parallelograms and all of that. It's all coming together to be able to solve for this. Now, I did not do this in the statement rationale format. I do want you to do that, and we're going to do that with the try it example over here, but I just wanted to show you the math in this one. Okay? So hopefully you can look at example 18 on page 217 and kind of see this for yourself and how you do it, but you need to use a number of different rules to help you out, but hopefully that's becoming easier. So let's do the try it. Okay? And I'd love to think about this one on your own for a minute, and Mrs. Bischoff, if you want, for so everybody can get a chance to look at it and think about it first. You don't have to write anything down right now. You can stop the video here. We'll get going, and we are going to do this. And rationale. Okay, everybody knows what a statement and what a rationale is. A statement is the solving part, what it is that you're actually solving, and the rationale are the reasons why you can do it, the rules that allow you to make those solutions. Okay? So here we've got a triangle, okay? And we know that the interior angles of a triangle are 180 degrees. And that we know that is a rationale, it's a rule or a property. Okay? So we are trying to solve for x and for y. Okay? So the first thing that we do is, what do we know? What can we use to help us figure out what x and y are? And let's go ahead and start with x. This is this exterior angle right here. Adjacent interior angle that's 44 degrees. Supplementary. They add up to 180 degrees. So we can say in our first statement, x equals 180 minus 44, or x equals 136 degrees. And the rationale for that are supplementary angles. This is the reason we can say this. All right? So that's the first statement, and we've solved for x. So we know that this equals 136 degrees. Y. A couple of ways. We could solve for this angle up here that's unnaturally to this, and then we know that exterior angle equals the sum of the remote interior angles, so that would be these two. Okay, but that's not what I want to do here, because that's not emphasizing the new lesson. What's emphasizing the new lesson is that this is an exterior angle, this is an exterior angle that we just found. And we know that all the exterior equal 360 degrees. It doesn't make any difference whether it's a quadrilateral, a triangle, a hexagon, an octagon, 15. All of the angles on the outside add up to 60 degrees. And you can extend in this. Okay. So let's use the exterior angle sum idea. And we know that they have to add up to 360 degrees. We're going to take 136 and add 111 to that. It's 240 degrees. And then I know that y equals 360 minus 247. Okay. So 360 minus 247 is 113. So y equals 113 degrees. The exterior angle sums equal 360 degrees. We can check that. We can go and say 136 and 113. Okay, so this is 9, 10, 5, 6, 360 degrees, so that works. And we know that this one is supplementary here. Interior is not what we're talking about right now. All right. So what I'm trying to get through to you is the idea that exterior angles equal 360 degrees. Interior angles are all about the number of sides and the number of triangles. We'll get lots of practice with this. There's a great YouTube video if you wanted to look at this more that explains this kind of the same way that I did. I think that it's a pretty simple explanation here that the exterior angles equal 360 degrees. For Monday's homework, and you started on this in class, you are to do the problem on page 219. You are going to do numbers 3, number 3 on page 219. And don't forget that you also have Academy that's due on March 4th when the next assessment is also taking place. And the next assessment will be all of chapter 7, which covers all of the vocabulary, the parallel, the transversal stuff, the quadrilaterals, specifically the parallelograms, all of that, and what we're looking at interior and exterior angles. We only have some time now to review for the test, but we're going to get through this section by mid next week, and then we'll be able to move forward to the test. So if you've got any questions, make sure you write them down. I know Ms. I'm happy to take them as well, but I think that you can look at the example on page 217 and get working on page 219, number 2 and 3. And this will be part of an assignment. I'm going to be collecting the assignment on page 219, numbers 2 and 3. 219, and also an additional assignment, which I will collect all of those when I come back on Tuesday, and that will be work grade for you, graded on accuracy. All right, so get going on numbers 2 and 3, page 219. And I will let Ms. Bischoff know what you're supposed to do on Monday, and I look forward to seeing you on Tuesday when I return. Thanks.